All right, so we're going to go ahead now and get started. And we're going to look at 3.5. We're going to look at question number 3 to begin with. And what we're doing on these is we're finding equations of lines. And you can either be given a point and a slope, you can be given 2 points, or you can be given a point and another line equation. And there's a similar question to this one on your practice final that you're going to get today. So question number 3, we have the point -4, -14, and we want it to be parallel to this line equation, which is 7x plus 9y equals a -91. Okay, so that's what we want. And we want this in slope-intercept form. Off here. Okay. And we have, remember, a flow chart that's going to help with that. And what do we have? Okay, we have a point and we have a line equation. So that's going to be your third page. And you can use this on your final. And so we want to find the equation of a line when you're given a point and a line equation. And what do we need to do? It says rewrite the equation in slope-intercept form and find the slope. So that's what we're going to do next. Is we're going to rewrite this, and so we're going to have to solve this for y. So we're going to take our equation and we're going to solve it for y. And that's going to give us then our slope. So move that 7x over. And now we have 9y equals a -7x minus 91. Divide by your 9. And that leaves me then with y equals now -7/9 x and a -91 over 9. So the number in front of your x is your slope once you solved it for y. So that's a -7/9. So when we have a point and a line equation, what do? We get out our flow chart. You can use that flow chart on your final. So you don't have to worry about not having that. You can use that. And what do? We find the one that says find the equation of a line given a point and a line equation. We begin by rewriting it in slope-intercept form. And then we look to see if it's parallel or if it's perpendicular. So ours is parallel, so we keep the same slope. If it's perpendicular, we use the opposite or negative reciprocal slope. And then we go back to point slope after that. And I always remember when I want to use point slope, which is our end result, we have to have a point and we have to have a slope, and we have those. So now we move on to point slope. So now we're going to use our point slope formula. And we're going to use our point slope formula with m equals -7/9 and also the point -4 -14. So that's where we're at there. So this is our point, x1, y1. And so now we have y minus y1 equals m times x minus x1. And we fill it in. And watch out for our double negatives here. So that's where we're at there. So we found our slope. We used that slope along with our point slope formula. Plugged in the values. Now we have to watch it and be careful with the double negatives. So these double negatives are going to make this a positive here. And it's going to make this a positive here as well. and then we'll distribute through that negative 7/9. So rewriting, we have y plus 14 equals, distributing through, a minus 7/9 x. And then we have negative 7 times that positive 4. And that's going to be then a negative 28/9. So we used our point slope formula. We plugged our values in. Now we need to know what we want to solve it for and what do we want our answer in. Well, if we go back and look, we want our answer on question number 3 in slope-intercept form. And what does slope-intercept form look like? It looks like this. Y equals mx plus b. So we need to go ahead and clear our fractions so we can solve it for y. So go ahead and multiply everything by a 9. That's going to clear out all of our fractions. And that leaves me then with, when we distribute through, 9y plus, we've got 14 times 9 here, which is then a 126. That equals now negative 7x minus 28. Almost done. So we're now going to move that 126 over. And that leaves you now with 9y equals a minus 7x. And those go together. And that's 126 and 28. Makes it then a minus 154. We'll divide by our 9 everywhere. And we'll see if we can reduce that down. And it doesn't reduce down any. So what's our final answer look like? Well, our final answer in slope-intercept form then would be y equals a minus 7/9 x minus 154 over 9. And that's going to be now your final finished answer. Okay, so you plug your values in. You can check it. You could plug in that minus 4, and you should get out that minus 14, and you do. That's going to be your answer on that. Is everyone all right with how I did that? And these are probably the most challenging questions you'll have because of the amount of work that's involved. And lots of steps, lots of places to make a sign error. So just be careful with that. Okay, but that's going to be now your final answer. And that is in our slope-intercept form, which is what we wanted. And that was question 3. We also asked about question 7. Okay, and question 7 is very similar to question 3. It's just that in question 7, we want it to be perpendicular. So we're going to go through the exact same process for question 7. But when we work with our slope, we're going to have to flip it over and change our sign. So for question 7, we've got this point 2, 2, and we want it to be perpendicular to minus 3x minus 4y equals 2. So we proceed the exact same way we did it before. What do? Just take that equation and we solve it for y. So let's go ahead and solve this for y. So minus 3x minus 4y equals 2. We're going to add that 3x over. And minus 4y equals now 3x plus 2. We'll divide by our negative 4. And we're going to reduce down if we can. And we can reduce this down a bit. And that's going to give us y equals now minus 3/4 x. And this will reduce down to a minus 1/2. So that's going to be our answer for the first half, which is our equation rewritten in slope-intercept form. And we know that minus 3/4, well, that's going to be my slope. Is everyone okay with how I got to that point? So we took our equation and we rewrote it. Now, students make mistakes and sign errors, and sometimes they forget what to do. They get to this point and they think they're done. You're not done. You're halfway there. So what do we need? Well, we need the perpendicular slope. So we need to find our perpendicular slope. This is our parallel slope. What would our perpendicular slope be? Well, our perpendicular slope that we're going to be using then is going to be a positive 4/3. That's going to be the slope that we're going to be using. How did I get that positive 4/3? For perpendicular slope, what do? You take the fraction, you flip it over, and change your sign. So we flip it over, and that gave us 4/3. It was negative, so now it becomes a positive 4/3. That's what we're going to be using. So now we've got half of it done. Again, go back to that flow chart if you need to. Right, we went down the perpendicular side, which says use opposite reciprocal slope. And where do we land? We land in the point slope formula. So now we're going to use the point slope formula. So use the point slope formula with m equals 4/3 and also that 0.22, which that's x1 and y1. And what's our point slope formula look like? Well, it looks like y minus y1 equals m times x minus x1. And fill our information in. So that's going to be y minus 2 equals 4/3 times x minus 2. I'll slow down a bit so we can see what we're doing. So let's recap what we've done. What did we do? Okay, we looked at our original question, and we said we have a point and a line equation. So we took that line equation, and we solved it for y. We got our slope. Now, unlike the previous one, we wanted the perpendicular slope. So that means we flipped it over, okay, and changed the sign. So that minus 3/4 became then a positive 4/3. Then we're going to apply our point slope formula. So we found our point, and the slope we're going to be using is that 4/3. We plugged our information in. Now we're going to finish it by distributing through and seeing what we're left with. So now we're left with y minus 2 equals 4/3 x, and we multiply on the top. 4 times a negative 2, well, that's a negative 8/3. So we're at this point. Now, what do we need to do? The directions tell us specifically. Write this in slope-intercept form, and slope-intercept form is right here. So we need to solve it for y. And how are we going to do that? We're going to begin by clearing our fractions. So multiply it by 3. And then we'll be able to solve it. So now we have 3y minus 6 equals 4x minus 8. We're going to add that 6 over. So 3y equals 4x minus 2. We're going to divide by our 3. And now what are we left with? Well, now we are left with y equals 4/3 x minus 2/3. And that's going to be now your final finished answer in slope-intercept form. So these are a little bit complicated because of all of the algebra. And there'll only be a couple of these on your final. Not very many at all. I think there's 2 of them, if I remember right, out of 30. So not very many of them. But we do need to know how to do these. that was question 7. So now let's look at question 12. And question 12 is a little bit different because question 12, we don't have an equation. We have 2 points. So move that back down just in case you're needing to copy it. Here it is. I'll just leave that up there for you. Okay, so for question 12, we've got 2 points. We've got 2, 4. And we also have 4, 6. And I believe on these, yep, we want it in standard form. So how is this one different? Well, we go back to our flow charts again. And when we look at problems like these, we have to ask ourselves, what do we have? And that's going to tell us how we proceed. So what do we have in this case? Well, in this case, we have 2 points. So that's going to be the second page of our flow chart. Let's find the equation of a line when you've got 2 points. And so what do? We use our slope formula. So it's similar steps, just a little bit different. 2 points, we use our slope formula. And so we write out our slope formula. Remember, this is x1, y1, x2, y2. And our slope formula is m equals y1 minus y2 over x1 minus x2. Make sure you put the y's on the top, and that's where students sometimes make a mistake, as they think the first number goes on top. It doesn't. It's the second. So now we have 4, right? That's our y part, minus 6. Down below, we've got our x's, so we've got 2 minus 4. And 4 minus 6, that makes it a minus 2. 2 minus 4, that makes it another minus 2. And that leaves me then with a slope of 1. So that's going to be our slope there. Now, what do we do after that? Okay, look at our flow chart. We were here. We found our slope. What do? Point slope. So now we use our slope, which is our m. So we've got the point. It doesn't matter which set of points we use. Let's just use the first one, 4, 6. And we're going to use that with, so we're going to use that with our slope of 1. And we're going to use that formula, y minus y1 equals m times x minus x1 with our point and our slope. And again, x1, y1, we fill it in. So that's y minus 4 equals 1 times x minus 2. We distribute through. And that leaves me then with y minus 4 equals x minus 2. Now, what form do we want? If we read the directions here, it specifically tells us that we want this in standard form for question 12. And what does standard form look like? If we go to the bottom here, standard form looks like this. All integers. X has to be positive, and x and y are on the same side. So we want it to look like this. So what do? We move that x over, and we add that 4. That way the numbers are on the right, variables are on the left, and we now have minus x plus y equals 2. But that's not going to be our final answer, because our x has to be positive. And how do we fix that? We fix that by distributing through a negative. That way the first piece, the x part, is positive. And now we have x minus y equals a minus 2. That's going to be your final answer, and that is in now standard form. Okay. And it's so easy to make an algebra mistake on these, so take your time. Use a calculator if you need to. You don't want to end up getting the wrong answer because you added 2 numbers incorrectly. So always on these, take your time to work through them. The last question from this section is question 15. And that's minus 1/5, comma 3/5 for your first point. And 1/5, comma 7/5. x1, y1, x2, y2. And we're going to get this one in slope-intercept form. So let's take a moment to think about what we have. What do we have? 2 points. Okay? So 2 points. We go to our flow chart. We've got 2 points. What do? Find our slope. We're going to clear out the fractions in a moment, and they're not going to cause us any trouble at all because they're going to be very, very easy to clear out. So that's going to be our slope. M is y1 minus y2 over x1 minus x2. We plug our values in. So 3/5 minus 7/5 over, down below, we've got minus 1/5 minus another 1/5. Fractions in this case are very easy to work with because what do we notice? Well, if we look at it, we should notice they all have a 5. So we can simply get rid of all the fractions by multiplying everything by 5. So that's going to make it very, very easy to work with. That's going to then leave us with simply 3 minus 7 over minus 1 minus 1, which 3 minus 7, 3 minus 7 is a minus 4. Minus 1 is a minus 2, and that reduces down to 2. So don't let the fractions bother you. They're very simple to work with. See how they all had that 5th? They all went away. Multiply everything by 5. It just clears those fractions right out. Now what do? Well, now we need to use this slope with one of the points in our point slope formula. So we're now going to use our slope, which is 2. And we're going to use that point minus 1/5, comma 3/5. And we're going to use this in point slope. And I always like to write the formula out. Y minus y1 equals m times x minus x1. x1, y1. So is everyone kind of understanding these? And again, you won't have very many of them on your final, but there'll be 1 or 2 of them. I think there's actually 2 if I remember right. I think there's one that's an equation and a point, and one that's 2 points. And I think there's also one that's a point and a slope. But you'll see that here in a minute when you get your practice final. So now we need to plug our values in. And that's going to be y minus 3/5 there. So we can keep that. And put parentheses around it if you want to. Just be careful with the negatives. And that's going to equal then 2 times x minus a minus 1/5. And we know the double negative here is going to make this positive. And we'll go ahead and distribute this through. And that's going to now leave me with y minus 3/5 equals 2x. Double negative made that positive. And 2 times that 1 makes it a 2/5. Now we could clear out the fractions, but we really don't need to. It's so simple. We can just move that 3/5 across because that 3/5 can go directly with that 2/5. And it's going to make it very, very easy to just add them together. So we don't need to clear our fractions out because we can get by without doing that. And we do want our answer in slope-intercept form. So normally we would clear out the fractions, but these can go together, right? They already have the same denominator. And so what do we have? We have 3/5 and 2/5. Those go together, make it 5/5, which is then 1. And so that's going to now leave me with my final answer of y equals now 2x plus 1. Okay, so that's what we're working with. And that's going to be our final answer in slope-intercept form. And you could have multiplied everything by 5 here and then moved it around and got the same answer. But we really didn't need to do that because these already have the same denominators. So I just said let's save a step and let's just add those together over to the side. If it was a 9 here, I would probably multiply everything by that 45. But we don't because they're just 5s, so they can go together. You've got a few questions to look at now. 14? Sure. Yep, no problem. Okay, question 14. Yeah, 14 is a little bit different here as to what we're looking for because of our slope. So 14, we've got 10, 7, and we've got 10, 3. This one's going to be a little bit different because of our slope. So we first need to find our slope, which is y1 minus y2 over x1 minus x2. And that is now 7 minus 3 over 10 minus 10. And that leaves us then with 4 over 0. And 4 over 0, or 4 divided by 0, is not 0. This is undefined. So we can't really use our point slope formula, can we? Right? Because it's undefined. And we need to think about when we talk about an undefined slope, what is that? Well, we've got an undefined slope, so we can't use our formula. Let's plot these points and see what we've got. It's either going to be an x line or a y line. We can remember that an undefined slope is an x line, or we can plot our points so you'll visually see it. So undefined slope, so let's plot our 2 points. We've got 10, 7, 6, 7, 8, 9, 10. Okay, so 10, 7 is right here. And we've also got 10, 3, which 10, 3 is going to be right here. Because there's 10. 10, 3 is right here. And if I connect them together, what do I get? If I connect those together, I get a vertical line. And remember, vertical lines are x lines, so this would be crossing the x-axis at 10. So my answer would simply be x equals 10. Why is it an x line? Because our slope is undefined. And if you can't remember that, and you get an undefined slope, plot your points and you'll see it.
Do you need to write down undefined, or do you need to...
Yep, this is what we want for our answer right here. Yep, x equals 10. Okay, because that's what your answer is. When you have an undefined slope, what does that mean? That means you have a vertical line. Remember that? I know it's been a while, but vertical lines have an undefined slope. And undefined slopes are vertical lines, and they are x-lines because they cross the x-axis. Conversely, if it was 0, what would it be? If your slope was 0, it would be a y-line and horizontal. Because remember, there are 4 types of slopes. If it's going up from left to right on a diagonal, it's positive. Going down from left to right on a diagonal, it's negative. If it's a vertical line, it's undefined. If it's a horizontal line, your slope is 0. So our slope is undefined, and that's going to be your vertical line, and your x components are both 10 here. So that's why your answer would be x equals 10, because it's undefined. Okay, so let's move on and try to work through some of these questions out of 3-6 next. So we're going to look now at question number 2. And this is a thinking question. And we need to see if we can check the origin, 0, 0. Is the origin a good test point in graphing this inequality in the form ax plus by is less than 0? Is that going to be a good point that we can check? Okay. Well, let's think about what we've got here. Can we plug 0, 0 in? What do we have on the end here? We have this 0. Okay, that means that this line is going to go through the origin. So I wouldn't want to check 0, 0 because 0, 0 would be on that line, because it goes through the origin, which is 0, 0. With the 0, 0 here, right, for our origin, and the 0 here, we wouldn't want to pick 0, 0, because that's going to be on our dotted line. Because if it's 0, that means it goes through 0, 0. So we would want to pick a different point. So on that one, I would say the origin is not a good point to pick because it's on the line. Had it been any other number, had it been a 5 on the end, okay, had this been a 5, it would be fine to use 0, 0. But because of that 0, when you graph it, it's going to go through the origin and you wouldn't want to use it. So you'd want to pick something else like 1, 1 or 8, 3 or a different point. So you would not want to pick the origin because of the 0 here, because that's going to fall on your line. Question 5. Now, question 5, most of the work has been done for you. Right, so on question 5, all we need to do is figure out if we shade above or below our line here. That's it. The line has been graphed. We just need to figure out where to shade. Now, when we look at this line, does this line go through the origin? No, right? It's below it. So we can check right here with 0, 0, because 0, 0 is nowhere near that line. So we're going to check 0, 0. We're going to plug it in, and we're going to see if it's true or false. So we're going to check right now 0, 0. And we've got y is greater than or equal to x minus 6. We're going to plug in our zeros. And that gives you 0 is greater than a negative 6. Greater than or equal to. Well, is 0 greater than or equal to that negative 6 there? Okay, is 0 bigger than negative 6? It is. So this would be true. So that means this half is true. The opposite half has to be now what? False. And where do we shade? The true half, which in this case is right here. So there is your answer on that one. You would just shade above. That's it. Line was already done. All you had to do was pick a point, and we could use 0, 0 because it was not on that line. Now, question 7, they don't give us the line. We're going to have to graph it completely. So question 7, there's a little bit more to it. So let's now go ahead and look at question 7. So it just has one more step on question 7. So question 7, we're going to have to graph this line, and we've got x plus 3y is greater than or equal to 5. Now, first off, let's remember a little bit about our lines. Greater than or equal to, less than or equal to, well, those are going to be represented by a solid line. Strictly less than, strictly greater than, those are going to get a dotted line. So when we look at ours is going to be represented by a solid line. So that's the first thing we notice, is it has to be a solid line. Now, what do we need to do? Well, we replace that with an equal sign, and we solve it for y. So move that x over. We just made that inequality in equals, just so we can get our equation. Move that x over. Now we've gotten to this point. We're going to go ahead and divide by our 3. And now we have y equals, when we reduce it down, a minus 1/3 x plus 5/3. So that's what we're working with. And how do we graph an equation like this? Well, to graph an equation, you need one of 3 different things. You can graph it from an equation. Okay? You can have 2 points and you connect them together to make a line. It's another option. Or you can use a point and a slope. Now, what do we have? We have the equation. So from this equation, we solve that equation for y. And we need to find our slope. And what's our slope? Negative 1/3. So that means we go down 1 and we go forward to the right 3 units. We also need our y-intercept, which is 0, comma, in this case, 5/3. Right? 5/3, that's your b. And that's your y-intercept. Now we have everything that we need to graph this line. We know it has to be a solid line. And if we don't know where to put that 5/3, well, let's use a calculator and see. Let's see what 5/3 is in a decimal. And on these, we just kind of approximate where it's at. So if I look at 5/3, what do I know? Okay, that's at about 1.6 repeating. Okay, so it's pretty close to what? Pretty close to about 1.5. So 1.5 for 2, somewhere around there. Okay, it's a little bit bigger than a half. We'll just say it's about 1.5 there. Now, you could even use 2 if you wanted to make it a little bit easier. But we know, okay, it's in between 1 and 2, a little bit closer to 2. So we're going to go ahead and find that. And we'll put it right about there. Okay, so there's our y-intercept at 0, comma 5/3. Now, what do we do from there? From there, what do we have to do? Well, from there, we're going to have to go down 1 unit. So that means we're going to go down 1, and then we're going to have to go over 1, 2, 3 units. So we go down 1, and then we go over about 3, and that makes our second dot. We can now connect these together with a solid line, and there is our line. Now, we are not completely done yet. Why not? because this is an inequality, and we've got one more step left to do. So our original equation was x plus 3y is greater than or equal to 5, so we're going to check 0, 0. Just so we know where 0, 0's at, 0, 0 is right there. So we're going to now check 0, 0. Plugging it in, we get 0 plus 3 times 0 is bigger than 5, and is 0 bigger than 5? No, 0 is not bigger than 5, so that would be false. This side is true, and one side's true, one side's false. So where do we have to shade? The true side, which the true side then is up here. So that is what your graph should look like. And that 5/3 just kind of approximate. If you want to put it at 0, 2, because 5/3 is pretty close to 2, that's okay. Not going to be an issue at all. When we graph these, we're just doing a sketch. It's something to kind of give us an idea of what it looks like. If we wanted an absolute perfect picture, we would use a computer. But we're doing these by hand so we can see how things relate. And it's not going to be a perfect picture, so we can approximate things. It doesn't have to be perfect. It just needs to look similar to this. It needs to go down from left to right, and you need to make sure you shade the top, and make sure it's a solid, not a dotted line. So we've got a couple more to look at. 2 more, and then we'll take a short break. Then we'll come back. We'll do 3, 7, and then we'll start reviewing, and I'll give you your practice final to start looking at. So we're going to look now at question 10. And I think we kind of talked about question 10 last time. And we've done these already, and this is just in my words how I would answer question 10. It says, in an inequality, how do you determine which side of the boundary line to shade? Well, what did we do? Okay, we picked a point, any point. Normally we pick 0, 0, and then we see if it's true or if it's false. And if it's true, we shade that side. If it's false, we shade the other side. So for question 10, we picked a point, you check if it's true or false, and you shade the true side. That's it. And one more, question 19. And we'll take a short break, come back, and look at 3, 7. 3, 7 is an easier section. There's not a lot to do in 3, 7. So this is what we've got here. And a hardware store has room for 600 bags of fertilizer. You can have some of the bags with fertilizer and some of them without. So we need to graph this inequality here. And this just basically says, okay, when I add them together, I get 600 or less. That's what that's saying, because you've got with and without fertilizer. And if I add them together, it's going to be 600 or less, because that's all I can hold. And you want to see what that would look like as a graph. And as you increase one, you're going to decrease the other, because you can only hold 600 total. So what are we going to do? I'll just graph this one on the paper here. So we've got this equation. This is question 19. And we've got x plus y is less than or equal to 600, because we can't have more than 600 total bags of fertilizer. And this one's easy to graph. Move the x over. And now we've got y is less than or equal to a negative x plus 600. And my slope is going to be a negative 1. And my y-intercept is 0, 600. We know it's going to be a solid line. And the numbers are large, but that's okay. So how are we going to graph this? Well, we've got that point 0, 600. So let's use 100 on our measurements here. So 100, 200, 3, 400, 500, 600. So we're going to start up here at 0, 600. Now when we talk about our slope being negative 1, well, we can replace that with a negative 100 over 100. So negative 1 over 1 is the same thing as negative 100 over 100. So we can actually just use these units here, and this is 100 down here as well, and we can just go down 100 and over 100. That other pen here. So we're going to go down 100 and over 100. So we went down 100, over 100, connect them together. We're going to use a solid line. And it looks like that. Now, why can I never go below 0, and why can I not go back further to the left? Well, these are negative values. Okay? And can you have a negative number of fertilizer bags? No. So that's why we have to stay in this first quadrant up here. Because if we go down here, that would mean, okay, we're having negative bags. And we can't have a negative number of fertilizer bags. You either have a positive number or you have none of them. But you can't have a negative. Now we do need to check, so let's check 0, 0. And the origin is at 0, 0, which is right here. And we're going to check to see if it's true or false. So we check that out, and that's 0 plus 0 is less than or equal to 600. And is 600 bigger than 0? It is. So that's true. So that means we shade below. So we're going to be shading below just like that. Okay. And that's what we want. And what this is telling you is all of these are possible solutions. And any variety I could pick in here will work. This is just the maximum we can have is 600 bags total. Let's go ahead now and take a short break. We'll come back. We'll do 3-7, which is an easier section. And then I've got a practice final and a take-home final for us to begin working on. So let's meet back here at, how about 9:35? So let's meet back here in about 10 minutes at 9:35.